Hello, Form 2 students. Today we will go through 10.3, Converse of Pythagoras Theorem. So please write down our learning target on your class workbook. Okay, the learning target is by using the converse of Pythagoras Theorem, we will be able to determine whether it is a right angle triangle and apply the Pythagoras theorem and also its converse to perform the proof, to find the length and also find the area of the figure. Okay, please write down on your class workbook. Okay, let's take a look on the difference of Pythagoras theorem and the converse of Pythagoras theorem. Okay, in this triangle ABC, you will see if in this direction, okay, given that angle C is equal to 90 degrees, then we can apply the Pythagoras theorem in this direction to use the a squared plus b squared equals to c squared. Okay, but if it is not given a right angle triangle, we need to do in the opposite direction, okay, for proof. Okay, if we can prove that a squared plus b squared calculation equals to c squared, if we can prove this relationship, then we can say angle C equals to 90 degrees. So this is to prove by converse of Pythagoras theorem. Okay, so the Pythagoras theorem and the converse of Pythagoras theorem is in the opposite direction. Okay, so make sure you are clear about the difference of these two. Okay, please write down on your notes. So this is the converse of Pythagoras theorem. Okay, if a squared plus b squared equals to c squared, okay, we need to calculate and okay, if it is correct. If it is correct, then angle C will equal to 90 degrees. Okay, so at the beginning, you don't know this one is 90 degrees or not. Okay, if you can see a squared plus c squared, b squared after calculation will equal to c squared. If this is correct, then angle C will equal to 90 degrees. Okay, so this is the proof. Okay, let's have some example on quick practice 10.7. Okay, determine whether each of the following is a right angle triangle. Okay, and state which angle is the right angle triangle. Okay, pay attention to the keyword determine. That means it can be yes or no. Okay, you need to judge it is correct or incorrect. Okay, so let's take a look on the example. X equals to 5, y equals to 9, z equals to 12. And this z is the longest side. So this is more likely to the hypotenuse. Okay, the longest side is more likely to the hypotenuse. So that this one is more likely to be 90 degrees, the right angle. Okay, so we will check X and Y. Okay, so let's get started. We are checking xz squared plus zy squared. Okay, we are checking these two lines. So state which side you are checking. Okay, equals to 9 squared plus 5 squared, 81 plus 25. So it equals to 106. Okay, and then we check the longest side. So xy squared will equals to 12 square equals to 144. Okay, so you can see that 106 does not equal to 144. Okay, so we will say because xz squared plus cy squared does not equals to xy square. Okay, so triangle XYZ is not a right angle triangle. Okay, so why could we draw this conclusion, not a right angle triangle? Because we apply the converse of Pythagoras theorem. Okay. Okay, and then next part B. Okay, for x equals to 15.5, y equals to 18, z equals to 22.5. So which side is the longest length and which one is more likely to be hypotenuse? Okay, so of course this one, the longest side, is more likely to the hypotenuse. Okay, and this one is more likely to be 90 degree, question mark. Okay, so we will check with these two lines first. Okay, these two. Okay, we check the line adjacent to more likely 90 degree angle. Okay, so we will check xz squared plus cy squared will equal to 18 squared plus 13.5 squared. And then after calculation, we can find the value that it is this one. Okay, after calculation. And we check the value of x, y also. And it is equals to 22.5 squared, which is this number. Okay, so you can see that these two numbers are the same. They are equal, so that we can say since xc squared plus cy squared equals to xy squared, they are equal. Okay, so triangle XYZ is a right angle triangle. Okay, why we can draw this conclusion? Because we apply the converse of Pythagoras theorem. Okay, so that we can draw the conclusion it is a right angle triangle. And also we need to state this one. Okay, this one. This become 90 degree. Okay, so we can say, so angle XZY is a right angle. Okay, so we have an example, which is the part A is not a right angle triangle, and part B, which is a right angle triangle. Okay, so be careful about the presentation when you are doing a proof. So now I'm going to show you some common mistakes which have the wrong presentation. Okay, so for this one, we haven't proved that it is a right angle triangle, so that we cannot write in a line. Okay, this is apply the Pythagoras theorem when it is given a 90 degree. Okay, we cannot do this when proof. Okay. Okay, so this one we write in a line is to apply the Pythagoras theorem. Okay, but not for proof. Okay, so you can see that finally it is not equal. Okay. Okay, and then another wrong presentation is that you only write down the number 13.5 squared plus 18 squared equals to 22.5 squared. It is only a calculation, but we need to state which side are we proving. Okay, we need to state the name of the side. Okay, so be careful to don't make this kind of wrong presentation, which will not bear marks in your quiz. Okay, for wrong presentation, no marks will be given. Okay, and then another example, question, quick practice 10.8. Okay, the figure show a quadrilateral and angle C given. Okay, given is 90 degrees. So for this triangle, we can apply the Pythagoras theorem. Okay, because it is given a 90 degree. Okay, given. Okay, and prove that triangle ABD is a right angle triangle. Okay, prove. That means we need to show by step. Okay, so for this one, this one, we don't know if it is a 90 degree. Okay, so we need to check by a squared plus b squared equals to something. Okay, calculation, and c squared equals to something, calculation. Okay, and check a squared plus b squared equal to c squared. Is it correct? Okay, so for triangle BCD, we apply the Pythagoras theorem, okay? But for triangle ABD, we apply the converse of Pythagoras theorem, okay? So this one is Pythagoras theorem. Okay, so this one is converse of Pythagoras theorem, okay? So let's get start. Okay, in triangle BCD, apply the Pythagoras theorem. BD squared equals to BC squared plus CD squared. Okay, so this one is Pythagoras theorem. Okay, so sorry for making a mistake here. Okay, so for part A, we apply the Pythagoras theorem by writing in one line. Okay, so BD, taking the square root, 6 squared plus 4.5 squared, so that it will equal to 36 plus 20.25 square root, so it equals to 7.5. Okay, so for part A, we given the 90 degree and we apply the Pythagoras theorem, we can find the BD equals to 7.5. Okay, so we write down in the figure for our reference later. Okay, and then next, after we have find BD equals to 7.5, and then in triangle BAD, now we need to check if this one is 90 degrees. So we check and apply the converse of Pythagoras theorem. Okay, so we check BD square plus DA square equals to 7.5 square plus 10 square. And after calculation, the value is this one. Okay, and then we check again the value of BA square. It will equal to 12.5 square, it will equal to 15625 also. So you can see that after calculation, we check, yes, they are equal, okay? So we can write down, since BD square plus DA square equals to BA square, they are equal, so triangle BAD is a right angle triangle. Okay, and of course the angle BDA, it will become 90 degree. Okay, correct. Okay, so the reason for the drawing the conclusion is converse of Pythagoras theorem. Okay, so in this example, you can find a difference between Pythagoras theorem and converse of Pythagoras theorem clearly. Okay. Okay, for part B. In part A, we have also proved angle BDA is 90 degree. Okay, and we have also find length of BD is 7.5. Okay, so we could find the area of ABCD. We can find the area of ABCD by calculating the area of these two triangles. Okay. So it equals to the sum of area of triangle BCD and area of triangle BDA. Okay, so it is equal to the base 4.5 times the height 6. Okay, so it equals to 4.5 times 6 divided by 2. And we could also find the area by the length dA and the height 7.5. Okay, 10 times 7.5 divided by 2. So we could find the value is 13.5 plus 37.5. Okay, so finally it will become equals to 51. Don't forget the units, cm square. Okay. Okay, and finally we will go through the consolidation corner. We will go through only the question 2. Take a look of the question. Okay, prove that angle CBD equals to 90 degree. CBD, okay? So we mark down to check if this one is 90 degree. We need to check, okay? So of course by checking using the a square plus b square calculation, and then c square calculation, okay? And check whether a square plus c square b square equals to c square. Okay, check, and then converse of Pythagoras theorem to prove. Okay, if you can see the proof, the keyword proof, then you do in this format and apply the converse of Pythagoras theorem. Okay. Okay, for part A, so this one is the longest side. Okay, so this one we need to check if it is a 90 degree. Okay, so we start with these two sides. Okay, CB square plus DB square equals to a square plus 6 square equals to 64 plus 36. So the value is 100. Okay, and we check also CD square, it will equal to 10 square, also equals to 100. Okay, so they are the same. So as BC square plus DB square equal to CD square, so we can draw the conclusion angle CBD equals to 90 degree because this is a right angle triangle, and the reason is converse of Pythagoras theorem. Okay, so we can prove that angle CBD is 90 degree. Okay, correct. All right, and then for part B, find the area of triangle ABC. This one. If we want to find the area of triangle ABC, we need to find the height times the base. Right? We need to find the base times the height. As this one, we have proved that this is 90 degree. So AB is the base and CB is the height, okay, divided by 2. So we can find the area of triangle ABC, okay? We take use of part A because angle ABC is 90 degrees. So we can find the height and the base to find the area of triangle ABC, okay? Part B. But the problem is we don't know the value of AB. We don't know the value of AB because we don't know the value of AD. Okay, so we need to find the length of AB first. So this time, because the angle ABC is 90 degree, so we can apply the Pythagoras theorem. Okay, AB squared plus CB squared equals to AC squared. Pythagoras theorem. AB will equal to square root AC squared minus CB squared will equals to 16 squared minus 8 squared. Okay, equals to 192 square root. But if you use the calculator, square root 192 will equals to 13.8564 something, okay? So it is not an integer, so we will keep the square root, keep the third form, okay? All right, and then so that AB will equal to square root 192, then we can find the area of triangle ACB will equal to AB times CB divided by 2. And AB is equal to square root 192 times CB is 8 divided by 2. So now we can, using a calculator, square root 192 execute, okay, times 8 divided by 2. The answer is 55.4256 something, okay? But we need to correct to, as refer to the question, we correct to the 3 significant figure. So it is 55.4, okay? Correct to 3 significant figure. Okay? Do you get it? Okay, so let's get some example in exercise 10C.